Hi, this is Alex Galt with Edina High School, and once again, we're looking at asymptotes, but unlike yesterday when we were looking at vertical asymptotes, this time we're looking at horizontal asymptotes and how that relates to what we've been studying this chapter, which is limits. So first, a definition. F of x has a horizontal function asymptote of y equals b. Notice that that's a y equals equation because horizontal asymptotes would be horizontal lines, so they would look like y equals. If and only if the limit as x approaches infinity of f of x is b, or the limit as x approaches negative infinity of f of x is b. I want you to note that it is possible for a function to have 0 horizontal asymptotes. If b is not a number, then we don't have a horizontal asymptote. A function could also just have one horizontal asymptote if both of these two limits are the same number, or if only one of them is a number and the other one is not a number, then you have one horizontal asymptote. Or it's possible for a function to have two asymptotes if these two limits don't match, but they're both numbers. Horizontal asymptotes are just the two ends of a function. So since there are only two ends, you can only have two horizontal asymptotes. You can't have a horizontal asymptote in the middle of your function. I also really want to emphasize, just like I did yesterday, that it is possible for a function to touch its horizontal asymptote. I want you to think, just quickly, about this function. F of x equals 4. If I think about that function, if I graph it, that function would look like this horizontal line. Now, if I think about as x goes to infinity, if I do the limit as x goes to infinity of 4, well, there's not even a place to plug in infinity, but that limit is going to be 4. And if I think about the limit as x approaches negative infinity, that's also 4. So f of x equals 4 is a horizontal line. It also has a horizontal asymptote of 4, which it touches all the time. So it is totally possible to touch a horizontal asymptote. Before calculus, when we talk about asymptotes, we talk about it as a line that you get closer and closer to, but you never really touch it. That's a bit inaccurate for what the actual definition of asymptotes are. You may touch an asymptote. All right. Here's how. These are the tools that you can use to find limits that involve infinity. First of all, if you're going to either positive or negative infinity, then this holds true. 1 divided by a really giant number, whether it's positive or negative, is going to get closer and closer to 0. So this limit would be 0. So one tool you can use is 1 over x is going to be a building block. Anytime I see a 1 over x, if I'm going to some kind of infinity, then that's going to be 0. The other tool I can use is what I call end behavior. And for end behavior, big exponents have a bigger impact on the y-coordinate than small exponents. So x to the third is going to be more powerful than x squared. Even 100x squared is less powerful than negative 3x cubed. Negative 3x cubed has a way bigger impact on your y-coordinate than 100x squared as x gets very, very big. The other thing is that exponential functions impact end behavior, but exponential functions are kind of special. They have different behavior on both ends. So if I sketch a picture of the e to the x function, maybe you'll see why. E to the x, remember, starts out really small and then goes shooting up. And so as x gets bigger, in this direction, my function is approaching infinity. But as x gets smaller, in this direction, my function is approaching 0. So e to the x has a huge impact, bigger than any exponent. E to the x has a huge impact if x is going to infinity, but it has almost no impact as x goes to negative infinity. So your higher exponent would take precedence in that case. So you really have to think as you're doing these, as you're making choices about your end behavior, is this exponential important right now, or is it not important? If I have an exponential with a positive exponent and I'm going to infinity, that's going to be huge. But if my exponential has a negative exponent and it's going to infinity, that's going to have no impact on my y-coordinate. So we're going to do a couple of examples together. These are on the note sheets that I provided if you're using those. So x is going to infinity, and we're taking the absolute value of 2x minus 9. First of all, which has a bigger impact on your y-coordinate? The 2x or the negative 9? And I think you'll agree that 2x has a way bigger impact as x goes to infinity than negative 9 does. So now we have the absolute value of 2x. X is going to infinity. So 2x is going to be positive because x is going to infinity. 2 times infinity, or 2 times a really giant number, would be a positive number. So that means that we could rewrite that as just 2x because the absolute value of a positive really doesn't do anything. So the absolute value bars are important if what's inside the absolute value is negative, but we know in this case that it's not. So our x's here cancel, and we wind up with 2. So this function right here has a horizontal asymptote of y equals 2. Now we're going to look at the other direction. So as x approaches negative infinity, and so I'm going to start with the same way, that 2x has a way bigger impact than negative 9 does. So I'm going to ignore the negative 9 and just focus on the end behavior. Because x is going to negative infinity, the negative 9 doesn't really do anything for us. And if you have a 2x, that's way more important. But in this case, if I take 2 times a really giant negative number, in this case, 2x is actually a negative number. So the absolute value bars really do something for us. They change the sign of 2x. So I'm going to change the sign of 2x. So just to emphasize, this looks like a negative number. Negative 2x looks like a negative number, but it's actually positive because x is negative, because we're going to negative infinity. Again, our x's cancel, and so we wind up with negative 2. So this particular function has an asymptote of y equals negative 2, as well as an asymptote of y equals 2. It has 2 different asymptotes. Here's a graph of what this function looks like. You can see this y-axis is counting by ones, and so as x gets really, really big, our function is approaching 2. So that's this part. And as x gets really, really small, our function is approaching negative 2. So we have 2 different asymptotes. And yes, our function crosses the asymptote. No big deal. It's allowed to cross the asymptote. That's fine. Okay, I would encourage you to pause here and try these ones. They're the same question, except we're doing our limits for the same idea. We're just doing a different function. So try it and see if you can make sense of this. And then restart the video when you're done. Okay, so if I'm going to positive infinity, 6e to the x is going to have the biggest impact on my numerator. That plus 2 is going to basically do nothing. In my denominator, I would choose the largest exponent, except the exponential is going to be way more important than the exponent. So I'm going to choose 3e to the x for the end behavior. The e to the x's cancel, so I get a limit of 2. So that means that this function has a horizontal asymptote of y equals 2. Now I look at the other direction, so now x is going to negative infinity, and now e to the x has almost zero impact on my y coordinate. So my dominant term in my numerator is 2. And in my denominator, my dominant term is going to be negative 4x to the 4th, because that's my largest exponent, and my exponential is having almost no impact. So x is going to negative infinity. I have 2 divided by a really, really giant negative number. So that's basically 0. And so that means that this function also has a horizontal asymptote of y equals 0. Here's a picture of this graph. You can see this as x goes to negative infinity, our function is approaching 0, and as x goes to positive infinity, our function is approaching 2. Okay, for this function, now we're looking at what are the horizontal asymptotes for this function. There's a graph shown here, so we're not going to cheat and use that graph, but we hope that our work will support what the graph shows us. So first I'm going to do the limit as x approaches infinity of f of x. So our dominant term in the numerator would be, well, e to the negative x is going to be basically 0 as x goes to infinity. So our dominant term would be 3x over x. So this limit would be 3. So that means that y equals 3 is an asymptote to the right for this function. We're going to do the same thing, but with the other in the other direction. So x goes to negative infinity. Now, e to the negative x, as x goes to negative infinity, is going to be really dominant. So that's going to be our dominant term in the numerator. And in the denominator, it's going to be x, but e to the x is way more powerful than x. So this function is going to, well, we have a positive number in the numerator and a negative number in the denominator, but the positive number is way, way bigger. So this is going to negative infinity. And so our function does not have an asymptote to the left. And we can see that in the graph, that our graph is shooting down to negative infinity, but it doesn't have an asymptote to the left. Okay, finally we're going to sketch a function with this behavior. So this is our last example. So the first piece of behavior that we want is as x approaches 0, our limit is infinity. And so that means that no matter which way I'm coming at it from, our function is shooting up to infinity. This is that vertical asymptote that we talked about yesterday, but both directions are both going up to infinity. And then the second piece is that our function as x goes to positive infinity is approaching negative 3. So I don't know what's going on with our function, but I do know that at some point it levels off to look like it's approaching negative 3. And as x goes to negative infinity, our function is approaching 1. So we're going to have it level off at 1. So we're kind of showing that with this sketch. Just so you recall, this is a vertical asymptote, but number 2 and 3 are the 2 horizontal asymptotes for that function. All right. Good luck. Have fun. Thank you.